sure everybody's very interested about. But in the setting of ARDS, of course, here we're speaking mostly about venous ECMO or VV ECMO, which is what we use to support respiratory failure. Very few patients with ARDS require either veno-arterial ECMO because of concomitant left ventricular or biventricular function or hybrid modes. It's important to note that even though we now understand that maybe up to a third of patients with severe ARDS have associated RV dysfunction or RV failure and may have shock as a result of that, that actually responds very well to support with VV ECMO and reversal of hypoxemia, delivering highly oxygenated blood directly to the pulmonary circulation as a very good vasodilator. And many of these patients have recovery in RV function that doesn't actually require any cardiac support from ECMO. So really the focus of ECMO support for patients with ARDS and respiratory failure is on the veno-venous mode. We'll speak a little bit about the future, which is the extracorporeal carbon dioxide removal, or ECOR, which is really in 2020 something that's under research investigation. I wouldn't say that at this moment we have enough data to suggest that it be used widely in any situation for respiratory failure, but there's a lot of interest in a number of ongoing clinical trials looking at the use of ECOR, both in ARDS and for other applications focused mostly on hypercapnic respiratory failure, since, as the name suggests, it mainly focuses on removing CO2. So things like asthma exacerbations and COPD exacerbations. There's actually a number of large clinical trials ongoing looking at the use of ECOR for COPD exacerbation. And the technology is not new. I'm sure you're aware that actually ECMO technology has been around since the 60s with the advent of cardiopulmonary bypass. These sorts of technologies developed together. And in fact, even in the early days of the 60s and 70s, the people, the pioneers, many who are listed in this trial that was published in JAMA in 1979, Warren Zapel, Don Hill, Bob Bartlett, Alan Morris, these people sort of imagined that this technology, which now could provide gas exchange, especially in patients who had very difficult and refractory respiratory failure, could be a boon for these kinds of patients where mechanical ventilation was either very difficult or really not desirable. You can think of a situation where a patient who has massive, barotrauma and pneumothoraces where using positive pressure ventilation was probably not desirable. So here they came up with this machine that they thought could really, if not supplement, replace mechanical ventilation in a lot of these difficult cases and difficult situations. And so went ahead with the blessing of the National Institutes of Health in the United States to do this trial in 8 centers across the United States in the 70s, looking at the use of ECMO in adults with severe acute respiratory failure. So they randomized 90 patients to mechanical ventilation or mechanical ventilation with ECMO. And what you could see here is the survival rates. The survival rates were dismal. They were 10% in both groups. So this told you 2 things. One is that if you're an adult with severe respiratory failure in the 70s, you're in big trouble, and that for what we knew then in the 70s, ECMO wasn't going to help you. And this study, unfortunately, dampened enthusiasm for ECMO in adults with respiratory failure for many, many years. And it wasn't until another pandemic, so not the one that we're currently in, but one just over 10 years ago, that changed our thinking about this. So despite the fact that that study by Warren Zapel dulled enthusiasm in many centers around the world, places that had developed expertise in extracorporeal circulation continued to refine the technique, refine the technology, a better understanding of the physiology of gas exchange and cardiopulmonary support on ECMO. So places like Milan, where Luciano Gadnoni and Antonio Pezzenti were, places like in Bethesda and NIH, where Ted Colabo, and in fact both Luciano and Antonio went to study with Ted Colabo there, was refining the technology and the gas transfer techniques related to ECMO. These places really, and Michigan, where Bob Bartlett still is, continue to refine the technique and improve our understanding of how ECMO might be a useful tool in these kinds of patients. And so that brings us to the H1N1 pandemic 10 years ago, where similar to today, clinicians around the world were admitting a lot of patients who were reasonably young, previously healthy, really very few comorbid or premorbid conditions, some of them even pregnant, with single organ failure and very profound hypoxemia, who are dying with severe ARDS, and they elected to put some of these patients onto ECMO to see if they could change the outcome. And here's perhaps the most high-profile case report or case series from that pandemic, published in JAMA from our colleagues in Australia and New Zealand, where they put 68 such patients onto ECMO because they were dying of life-threatening hypoxemia. And interestingly, what they found at the time of publication was that nearly 71% of these patients survived to ICU discharge. And by the time they followed all the patients up after publication, it was actually 75% had survived to ICU discharge. So that was a dramatic change, because 30 years prior to that, in 1979, survival was 10%. And now in 2009, survival was 75%. So a major shift, again, lots to do probably with just general critical care improving, our understanding of managing critical illness and mechanical ventilation improving, but definitely improvements again in our understanding of what kind of patients to put onto ECMO, so patient selection, the physiology of gas exchange in these sorts of situations, and the technological advancements that occurred in those intervening 30 years probably had something to do with these much improved survival that was seen in this case series. And so this led to this dramatic increase in the amount of ECMO that was being used in adult patients. And so these are data from the Extracorporeal Life Support Organization Registry, housed in Ann Arbor, where you could see that for many decades, after the sobering results of that trial in adults in 1979, the use of ECMO in adults was really quite low. And this is really something that was in the toolbox of neonatologists and pediatric intensivists for many years. But then along came H1N1 in 2009, where you see this initial steep rise in cases, probably related to the management and support of ARDS patients. And then in the last few years, this even steeper rise, which probably also encompasses the use of ECMO for cardiac indications such as refractory cardiogenic shock and ECPR in the setting of refractory cardiac arrest. So really now adult cases are outstripping traditional use in neonates and pediatric patients for all of these indications now. So following the results of these enthusiastic case series, we have the first modern randomized control trial that came after that study by Zapel and colleagues in 1979. This is the CSER study, which I'm sure you're all familiar with, led by Giles Peake, who's a cardiothoracic surgeon at the time in Leicester in the UK, now is working in Florida. And this trial actually tried to answer the question in the modern era of whether VV ECMO was useful in patients with severe ARDS. And here what they did was they randomized 180 patients to getting best conventional management in the hospital that they showed up to in the UK versus being transferred to Leicester, which at the time was the only adult center for ECMO in all of the UK, for consideration of ECMO. Their primary outcome was 6 months survival without disability, and what you can see here is the Kaplan-Meier curves and the point estimate that indeed suggested that for their primary outcome, being sent to Leicester and being considered for ECMO was associated with a benefit and a statistically significant improvement in 6 months survival without disability. And of course, all of us in the field, and I'm sure you as well, we were hoping that this trial would finally answer that important question of should we be using ECMO, and is ECMO the thing that's saving lives in patients with severe ARDS? And what you can see here, of course, is this dangerous little asterisk beside ECMO, because the results were challenged because of a number of problems. And chief amongst them was the fact that of the 90 patients who were randomized to ECMO and transferred to Leicester for consideration of ECMO, 25% of those patients actually never got onto ECMO. And I'm sure much like in referral centers such as your own, what happens is that when these patients get sent from community hospitals or smaller hospitals to your center for ECMO consideration, sometimes they end up not needing it. You change the mechanical ventilation settings, maybe you give a trial of proning. At this time, they were giving things like inhaled nitric oxide and high-frequency oscillation. You do some other optimization, and indeed, just like there, in this trial in CSER, 25% of those patients improved and never needed ECMO. So this, in the end, was less a trial of ECMO versus no ECMO, as it was a trial of if you send patients to a tertiary or quaternary center for ARDS with expertise in all kinds of things, including ECMO, that's associated with a benefit. And perhaps it's not just the ECMO that's important, it's all those other things, those intangible things at a referral center or expert center that led to the benefit. So skeptics, of course, abounded, and probably with reasonable arguments, given that we all know that ECMO is a very labor-intensive, it's a very invasive and risky intervention. It's costly and technically challenging to deliver for health systems around the world, which are already under tremendous pressure. So we want to be very certain, I think, for an intervention like ECMO, or as certain as we can be, that it is beneficial and in whom it's beneficial before we deploy it in health systems around the world. So our good friend and colleagues in France, led by Alain Combe, decided to launch the EOLIA trial, which was published just now 2 years ago. We were fortunate to be a study site for EOLIA in Toronto. But this was a trial that tried to pick up on some of the challenges that Caesar highlighted, and finally, hopefully, answer the question of does VV ECMO lead to a benefit in adult patients with severe ARDS. Here, again, everything was protocolized. Only expert ECMO centers were used, so there wasn't that need specifically to transport these patients to a centralized center to receive ECMO. Control group mechanical ventilation was also heavily protocolized. And here, the primary outcome was 60-day mortality. And the plan was an adaptive trial design, originally looking to enroll 331 patients. But what you can see here is the Kaplan-Meier curve again. And the trial was stopped after enrolling 249 patients because of futility. And again, important to understand that when we talk about stopping trials for futility here doesn't refer to the intervention being futile, but the fact that if we had continued enrolling to 331 patients, we were unlikely to show a statistically significant result based on our a priori power calculation. So rather than spending time, money, and resources to continue the trial was stopped here at an interim analysis of 249 patients. But interestingly, what you can see here is the Kaplan-Meier curve, and again, it seems that, at least crudely, there was a higher survival in the ECMO group compared to the control group, and here you can see the point estimate that 60-day mortality was indeed 11% less in the ECMO group compared to the control group, which led to a risk reduction of 0.76, which was not quite statistically significant here or in the log rank test on the Kaplan-Meier curve. So no time today to talk about the wisdom and the changes that we need to make in the field about stopping the dichotomization of clinical trial results to being good or bad or positive or negative because of the almighty p.05. But this was a challenge. And again, one of the reasons that this didn't reach statistical significance is the large number of crossovers that we had. So 28% of control patients crossed over to ECMO in this trial because, again, we wanted to conduct ECMO in high-quality centers, which were used to providing ECMO to these kinds of patients. And in order to have equipoise for randomization, the protocol had to include a rescue option for patients who were failing control strategy treatment or mechanical ventilation, including prone positioning, deep sedation, neuromuscular blockade, and these sorts of things, as these patients would have been treated in these kinds of centers if they had showed up outside a clinical trial. As you might imagine, these patients that required a crossover were the most sick patients in the trial. They had to have an oxygen saturation of less than 80% for more than 6 hours before they could cross over. And as a result of that stringent criteria, 9 of them were actually undergoing cardiac arrest at the time that they crossed over to ECMO. So they were the sickest patients in the whole trial. So the crossovers likely were a major reason why we didn't see a statistically significant result. We did a number of secondary analyses that suggested, again, a benefit for ECMO. So when you looked at a composite outcome of treatment failure, which included death or the need to cross over at 60 days, that was heavily in favor and statistically significantly in favor of ECMO. We performed a post-hoc analysis using a strategy, an analytical strategy commonly used in oncology trials where crossover is frequent between different chemotherapy regimens, and in this rank-preserving structural failure time model, that also led to a hazard ratio that was favoring ECMO. And most of the secondary outcomes in the trial, even the incidence of stroke, was better in the ECMO group. So outside of statistical significance, a lot of the analyses supported the idea that there probably was a benefit for ECMO in the EOLIA trial. So moving away from this frequentist interpretation of the results, and a nice editorial on the trial by Jeff Drazen, the former editor of the New England Journal, who sort of suggested that even though traditionally negative, there's something important to learn from the trial, and that likely was a benefit, even though the statistical significance wasn't there. So we tried to play from those wise words from Jeff Drazen and do this post hoc analysis using a Bayesian framework of the EOLIA trial. This was led by my colleague Ewan Gallagher, also in Toronto. And I want you just to focus on this, this top line here. And a Bayesian analysis, in brief, is something that we're very used to because it's typically how we think about things at the bedside as clinicians. We take the information that we know, for instance, the patient's history, physical exam findings, some investigations, and then we want to make a diagnosis. So we do a diagnostic test. The test is the sort of intervention, and we take our prior knowledge plus the results of the test. Those merge together to give you this posterior probability, which is here listed on the y-axis, of the diagnosis being true, the prognosis being whatever, the result being whatever. So Bayesian analysis is very intuitive to clinicians because it takes prior knowledge, adds the new knowledge, the new test, the new whatever, and combines them together to give you this posterior or after probability of what the result should be. And so that's what we did here, where the prior knowledge was either here on the right, the data. So this is basically a meta-analysis of the trials and some observational data before EOLIA came. And we downweighted some of that data because of some of the caveats we talked about, particularly in CSER. Or you can use this sort of situation called reference prior. So you could take clinicians who are either very strongly skeptical about ECMO in terms of their prior belief, all the way to being very strongly enthusiastic in their prior belief about ECMO. And here we modeled the idea of any benefit, so a relative risk anywhere less than 1. And what you can see here is that when you added EOLIA data to these reference priors, or you added EOLIA data to the meta-analysis of prior knowledge, no matter how it sat, no matter how you downweighted the prior data, or even amongst patients that were clinicians that were strongly skeptical, there was a very high chance that ECMO had a benefit. So even amongst the strongly skeptical, there was an 88% chance after you incorporate data from EOLIA that ECMO is beneficial in patients with severe ARDS, reaching all the way to 99% in those who are either moderately or strongly enthusiastic. So again, more data, more evidence that ECMO is likely beneficial. And this led Derek Angus, who's the deputy editor at JAMA, to say, so we don't need to ask anymore if ECMO works. That seems to be answered by EOLIA and this analysis. And now the key is obviously to ask, by how much does ECMO work, in whom, and at what cost? A traditional meta-analysis led by my colleague Lavina Munchie also suggested the same thing. If you look at CSER and EOLIA together, that favors ECMO. If you add some quasi-randomized trials, most of them from H1N1, with some matching, that also still leads to a benefit for ECMO. And then in this neat network meta-analysis from one of my graduate students, Hiroko Aoma, shows that, again, if you make some indirect comparisons to all these sorts of interventions that we commonly think about in severe ARDS patients, where we have lots of head-to-head trials looking at things like prone positioning and lung protective ventilation, or neuromuscular blockade and lung protective ventilation. We don't have a lot of other head-to-head trials looking at, say, prone positioning versus neuromuscular blockade. And in a network meta-analysis, we can get some of these indirect estimates. And the interesting thing, just to summarize this sort of complex-looking slide, is that what Hiroko found was that indeed, as you might expect, is that when you look at the network and look at all the direct and indirect comparisons, the two interventions that came out on top were prone positioning and VV ECMO. And if you rank the probability, much like in a Bayesian analysis, of these having any benefit, again, the top two interventions were VV ECMO and prone positioning. In terms of what Derek had mentioned about what the cost is, interestingly, VV ECMO, when deployed in these young patients who are previously healthy, have very few comorbid conditions, it's actually quite cost effective. So this is data from, again, another one of my colleagues, Callie Barrett, as a part of her master's degree in the London School of Economics, showing that if you compared using VV ECMO in these patients with lung protective ventilation, you actually gain typically about 4 quality-adjusted life years. And when you looked at the incremental difference in cost, that led to this sort of commonly used metric in cost-effectiveness studies called the incremental cost-effectiveness ratio of 36,000, this is Canadian dollars, per quality-adjusted life year. And when you look at many, at least developed country health systems, so let's use the United States, which maybe not the greatest example, but in the United States, anything that's less than $50,000 or $100,000 per quality adjusted life year would be considered cost effective. And maybe to give you a benchmark, something like dialysis for chronic renal failure typically costs about $55,000 per quality adjusted life year. So in the right patients, not only could VV ECMO be beneficial, but could also be cost effective. And here's the real challenge. So are we going to have better data to help us understand whether we should be doing this or not? The answer is no. Okay, and from this nice editorial from Luciano and Michael Quintel, it's the issue of feasibility is a major challenge for this kind of technology in the ICU. ICU trials in general are pretty challenging. In the CSER trial, they only enrolled 0.03 patients per unit per month. It took 9 years to complete. In Eolia, we did slightly better than that, but took 6 years to complete. And even in a randomized trial, over these many years, secular trends can bias the results. So a good example is in Eolia. In the middle, we had to make a protocol change because ProSiva came out, and now we had to start mandating prone position as part of the control group strategy because that was now becoming the new standard of care. And if we wanted to confirm the 11% absolute risk reduction in Eolia that we saw, that would take over 600 patients. And with 100 units enrolling at these rates, it would take almost 10 years to complete. So we're not going to have another trial. And like many things in medicine, we're going to have to make our best decisions based on all the data that we currently have about the utility of VV ECMO in ARDS. So moving to the current pandemic. So here's a picture. I actually, I don't know if you want to say lucky or not lucky. I was in Wuhan for the first and only time, actually last summer for the Chinese Critical Care Congress, and did visit the market where the outbreak is believed to have occurred. Here's a picture of that. Well, it's not my picture, but a picture from Google. And of course, this is the COVID crisis. And, I don't know if you guys are interested in discussing, but there's a lot of debate back and forth. And I saw just today a letter in response from Luciano and colleagues from Italy about whether, ARDS, COVID-19 is ARDS or isn't ARDS. And I think, again, it's less the issue of having any definitive answers on that. But again, the data at present would suggest that in the vast majority of cases, maybe not all, when you look at things like compliance across recent cohorts that I've published and presented that a lot of these statistics are pretty much in line with prior trials or large observational studies of ARDS patients. We know that ARDS is heterogeneous. It was heterogeneous when first described by Ashbaugh and Petty in 1967 in the Lancet article. So we know that there's going to be some heterogeneity, but at least from the ventilatory parameters, the compliance that's been reported, and the PF ratio, the vast majority of these patients would have otherwise been enrolled into trials of ARDS. And they, on the whole, seem to represent what looks like ARDS patients. So certainly the starting point would be to consider them to have ARDS, but of course, we'll let the data guide us. And as more and more data comes out every day, our understanding of COVID-19 changes, and whether there's an underlying or associated endotheliopathy, a vascular sort of phenotype or component that's more prominent in some patients. Like as we learn more, obviously our mindset and view of this might change, but at the moment, at least from a respiratory mechanics, ventilation, ventilatory parameters point of view, it seems very much like traditional ARDS. And ECMO is being used across many jurisdictions like gangbusters. So here's just a screenshot from yesterday from the ELSO registry, where they now have over 2,000 cases that have been reported on ECMO. Amongst those for which they have some kind of outcome data, the mortality rate is 55%, which is a bit less than traditional. When you look at the registry for ARDS for all comers outside of COVID, the mortality is actually, or the survival is actually closer to 65%, maybe nearly 70%. And interestingly, viral pneumonia typically flu has the best outcome. So with survival approaching 75% in the registry, you can see here that it's quite a bit lower for COVID, again, perhaps because of this heterogeneity in the presentation and the fact that it's not all related to maybe gas exchange abnormalities and severe ARDS, which contributes to the poor outcomes that we're seeing in some of these patients. Just a quick, for those who are not aware, so your country is a lot bigger than our province. It's 2.5 times as big. So we often have to contend with a very large land area. We're like the only major referral center for ECMO in our province of 14 million people, but you have a much larger land area to contend to. So not on this, like for instance, Ontario is larger than France or Germany, which have many, many more ECMO centers than we do. We literally have about one ECMO center for our 14 million people. There are a few others in some of our neighboring universities, but they don't do a lot of retrieval or referrals outside sort of their local region. Our experience for COVID up till now, unfortunately now, actually as of yesterday, we actually have no COVID patients in our whole hospital system, which has been sort of a great success from our public health measures here in Ontario. But over the pandemic, we put 33 patients with COVID onto ECMO. One of them actually went on twice, so there's 34 cannulations. We tried to not retrieve these patients if possible because of the potential risk of being in the enclosed space of the ambulance and the uncertain sort of availability of PPE and other equipment at referring hospitals. So we actually transferred a lot of patients early to our hospital when maybe we would have traditionally waited a bit longer, but just in case they needed ECMO, we transferred them to our hospital early, and that reduced greatly the number of mobile ECMO runs that we ended up doing. The average age was 49, so relatively young. Most of them were male. We put all of them onto VV ECMO. All of them, save one, were using a classic IJ femoral sort of two cannula configuration. And one patient, we couldn't cannulate actually their femoral veins easily, and so went on to a dual lumen configuration. And we actually proned one patient that was a very prolonged and very hypoxemic patient with COVID during this experience. Our outcomes are somewhat comparable to the ELSO experience, although we don't have final outcome data on all the patients yet. 67% survived to decannulation, but we had quite a few deaths on ECMO. The mean duration was just over 2 weeks, and 52%, so in line with the 55% survival to hospital discharge amongst the patients for which we have outcome data. I think interesting to us in Toronto, would be very interested to hear your experience, which has not been that of our colleagues around the world, is that the vast majority of deaths on ECMO were related to intracranial hemorrhage, with 6 while on ECMO and 1 the day after the patient was decannulated, so probably related to the ECMO. We had very actually little circuit thrombosis, actually, so not any more than we usually would in our case, where, again, other centers were reporting usual rates of intracranial hemorrhage, but much higher rates of circuit thrombosis, which was not the case here in our situation in Toronto. So again, 64% of our deaths were due to intracranial hemorrhage. These were actually more often in young patients. And after sort of a moderate range of being on ECMO, the interesting thing is that we used our normal low-dose heparin nomogram. And in fact, again, in asking around centers around the world, most centers had increased the amount of anticoagulation they were giving on ECMO because of this fear of thrombotic events, vascular complications. Some places also giving aspirin on top of anticoagulation. And they actually saw what they reported to me, at least, their usual intracranial hemorrhage rates, where we saw nearly quadruple the number of rates that we would see in this COVID population. So something that we need to work out. And again, nothing that we could detect that everybody had a PTT that was in target range before their hemorrhage was detected. None of them had low platelets, sort of a disturbed INR. So it's a very strange sort of thing. We wonder if it's an exacerbation of this underlying coagulopathy and critical associated microbleeds. So there's some data now, even in ARDS patients in general, that they typically have these microbleeds, and now if you're anticoagulating them, that might make things worse. And this entity that now has been called this critical illness associated microbleeds might be the situation. And at least in one autopsy series from Germany, it seemed that there was early evidence, even though the patient didn't die of it, that there was pronounced brain involvement in many COVID-19 patients who died, and that may or may not have contributed to their fatal outcome. So more data, and in fact, in the ECMO Card Global Registry study, which is a sub-study of the Sprint-SARI network, there is a group looking specifically at intracranial hemorrhage rates to see what this looks like around the world. We're very interested in hypercoagulability, which again seems to be part of the phenotype of this study. One of our fellows from Switzerland, Damien Ritano, is leading a study called TEGMO, where we're trying to titrate anticoagulation and blood product management to physical elastic tests rather than traditional tests like PTT or fractionated heparin levels. Here's just a quick example of how you can see two very different patients, one way more hypercoagulable than the other, early in the course of their ECMO treatment. You can see vastly different sort of static parameters suggesting a very hypercoagulable state versus one that's more moderately hypercoagulable. And interestingly, despite this, big difference in their profile, both were decannulated, both survived to ICU discharge, and both didn't have any circuit complications or DVT after being screened from decannulation. So again, very different hematologic presentation, but very similar outcomes, and again, more to learn from this study. And then one of our other fellows from Mexico, Ricardo, who's very interested in the weaning aspect, which is not well standardized, and what respiratory efforts have to do, something Jose is also very interested in. So we've been monitoring these patients with occlusion pressure and P.1 when possible. It seems that many of these COVID patients have extremely high respiratory drive, requiring large doses of sedation and very high sweep gas flow rates to modulate that drive when possible. And again, this idea that perhaps there is this contribution of high drive or patient self-inflicted lung injury that contributes to late failure. The vast majority of patients we put onto ECMO after they had already been in the ICU for about 5 to 7 days and then failed. So whether there is this contribution of high inspiratory effort or drive that might be contributing to that. We did some daily assessments for readiness and sweep off trials, much like we would do spontaneous breathing trials. And in many of these patients, we could actually get them off ECMO much sooner than some of our more traditional parameters might have been. And so this is something that Ricardo is working hard on. We hope to have more data on soon. You might have seen this was just published yesterday in the Lancet Respiratory Medicine. So again, from our colleagues from Paris, from L'Atelier, Mathieu Schmidt and Alain Combs, one of Europe's very largest ECMO centers. They reported 83 COVID patients. So their results vastly better than ours. In a much larger sample of patients. So what you can see here is that up to 90 days, where very few patients were left on ECMO, they had a survival rate of nearly 60% in these patients, and some were still in the ICU but off ECMO, and hopefully we'll also have good outcomes. So in a very large and experienced ECMO center, again, in the right patients, you can have very good outcomes. Maybe just to finish with some ideas of what next. So we talked a lot about these patients with very severe ARDS who need full-blown ECMO. That's actually a very small group of ARDS patients. There's this whole group in the middle with moderate ARDS, where again, this idea that using low-flow extracorporeal CO2 removal might allow for to facilitate the delivery of ultra-protective mechanical ventilation, which can lead to further reductions in ventilator-induced lung injury, and hopefully that would translate into better outcomes for these patients. And again, the idea here is that this is a much larger population at risk, so more bang for your buck if this kind of a strategy would work than a small group of patients who might fail outside of a pandemic, have very severe ARDS, and have life-threatening hypoxemia that need VV ECMO. So this is the idea of delivering, very low tidal volume or very low driving pressure, very low respiratory rate ventilation to patients to see if that would lead to a benefit. So here's just one study that we conducted called the Supernova trial in conjunction with the European Society of Intensive Care Medicine. In moderate ARDS patients sedated and paralyzed, we tried to reduce tidal volume to 4 mils per kilo, and this is a safety and feasibility study to see if it could be done. PEEP was adjusted to keep moderate levels of plateau pressure, and the idea was to keep PaCO2 within 20% of baseline. Safety and feasibility were the main outcomes, and in the vast majority of patients, we could reach the target tidal volume using CO2 removal to manage the hypercapnia and respiratory acidosis. As a result of the lower tidal volume, most had a concomitant reduction in plateau pressure and driving pressure, with an increase in PEEP to maintain the lung open. No real changes in other physiologic parameters. A number of important adverse events, which were not related to the device, but these are the things, the trade-offs that we'll have to see in a larger efficacy study, whether the trade-offs of any potential benefits of this ultra-protective strategy as they're weighed against device-related or anticoagulation-related adverse events. And again, these are just data recently that we published from Martin Erner, who, again, the idea that we can now see that driving pressure seems to be an important target in these patients. We can see that driving pressure, increasing driving pressure almost linearly increases the risk of death. It's actually a pretty consistent association across follow-up time, so it's not just dangerous early, although it might be slightly more dangerous early, it's still dangerous in the middle and even for some at the end. And really that if you want to get the maximum benefit of delivering very low driving pressure, at some point to deliver minimal driving pressure, you're going to need something like extracorporeal support to facilitate the delivery of very low driving pressure ventilation. So the idea here that, again, as a target and how you achieve that, again, could be just by lowering tidal volume, but this may be a very important strategy of mechanical ventilation in patients that could be tested in one of these future trials. So still lots to learn about all the aspects of ECMO, how to anticoagulate, how to manage blood products, how to mobilize, how to ventilate, how to regionalize. These are all things that we need to learn. And of course, in the end, what we need is data and not just conjecture and physiologic rationale, which is the starting point, but not the end of what we need to do. The good news is that data is coming. So here's such a study from the UK led by James McNamee and Danny McCauley called the REST trials. Actually was stopped earlier this year pre-COVID. It was supposed to enroll over 1,100 patients to ultra-protective ventilation with ECOR versus best mechanical ventilation, conventional mechanical ventilation. So we're hopeful that the results of this study will be out this fall, given that it stopped earlier this year. The Son of Supernova will be based on our safety feasibility study, will now be sort of trials conducted in France, Italy, and North America, looking at the delivery of ultra-protective ventilation in patients with ECOR compared to best conventional mechanical ventilation. And the idea would be to harmonize our data collection and outcomes for an eventual individual patient data meta-analysis. Neil Ferguson and I are leading the sort of North American branch of this trial. I'm happy to have been funded by CIHR to undertake this trial, which we were just getting started before COVID hit, and so it's been a little bit on the back burner, but hopefully we'll get started soon now that COVID, at least in Canada, has abated, with a number of Canadian centers and a few US centers as well. Maybe just to finally plug the idea that there's a need for an international research database, which we're creating in conjunction with ELSO, that we hope centers in Argentina might be also interested in participating in. This is a partnership between academia, industry, and regulators such as NIH and FDA to collect high-quality data on ECMO use across the world to facilitate research and provide infrastructure for future clinical trials. So hopefully we'll have more information on this for interested sites in the near future. And then, of course, the future, will we need mechanical ventilation? Some people don't think that will be true. We'll have to wait and see. At least at the moment, very few studies like this one in Germany, where they tried to use ECMO as the primary form of respiratory support. You can see here very mixed results, very mixed patients, and very small study, obviously, but about half survived, half died. We're very far off, I think, from considering a massive paradigm shift where ECMO becomes the sort of the standard primary support modality. Still a lot to learn about the interface between ECMO and mechanical ventilation. So just to finish, ECMO is a promising technology for the management of patients with ARDS. I think that the refinements in patient selection and technological advancements over the last few decades has really helped a lot. We have lots of encouraging observational and clinical trial data. More rigorous data is coming, which is good, from studies like REST, Supernova 2, our study in Canada, Ultimate, amongst others. And until then, the use should be limited to experienced centers. We really need to ensure that we maximize all the other evidence-based interventions. And of course, particularly in the COVID period, since these patients can deteriorate quickly, early referral as needed is key. So thanks very much for listening, and I'm happy to take any questions for anybody who has questions.